So we will see today a reflection principle, or it is called Shiva's reflection principle. Shiva's reflection principle. But I need to first set some terminology. Suppose D is a domain. D is a domain in C, and then its reflected domain, its reflected domain, uh, which is D, which let us denote it with D star, uh, is the set of conjugate images of all points of the domain D. So what it is? See, if you have anything here, if this is D, then any point here Z, for example, this Z is x plus iy, then you know what is Z conjugate. Z conjugate is x minus iy. That means it has to be its mirror image through x-axis. It has to be here some point. It has to be x minus iy. That means its reflection is nothing but its mirror image through a real axis. So this is somewhere the exactly domain D here. This has to be its reflected domain here. This will be a reflected domain. This will be the images. Another thing that another thing that we might require to say, when we say that something is symmetric with respect to real axis, symmetric domain with respect to real axis uh, uh, is a domain is a domain is a domain D such that its reflection is the domain itself. Its reflection is the domain itself, and of course, in this such domains, for example, let me take the simplest example. If I take a disk with center origin of any radius, this is an arbitrary disk, then in this case, if you have any point here Z, then its reflection will be here. It is Z here, its reflection will be again in the disk, and same way, whatever point you choose, its reflection is going to be again back in the same disk. So that means in that case, we might say that this is a symmetric domain. This is symmetric domain with respect to real axis. Okay, there might be other also. Analytically, you can define. You can see it as, for example, if I consider this disk to be 0 of radius r, then uh, to see that it is symmetric with respect to real axis means d star is equal to d. I have to take z in D. Z in D means mod of Z is less than R, and but you know that mod of Z is same as mod of Z conjugate, and that is to say, hence mod of Z conjugate is also less than R. So it implies that Z conjugate is also in D. Z conjugate is also in D. So with this, it follows that D star is equal to D. Now, beginning with the harmonic functions, let me state a lemma which will be utilized in the proof of the reflection principle for harmonic functions. And the lemma states that if U is a harmonic function, U is a harmonic function on on some domain T, and suppose you have a function U star of Z defined as U of Z bar for each Z in the reflected domain D, then U star is also harmonic in reflected domain D. So uh, this is how it will work. And to see that it is actually harmonic, it is since U star of Z is nothing but it is a composition of conjugate map, and U is composition of continuous functions. U is continuous, and you know that conjugate map is also a continuous function. So this is composition of continuous functions, continuous functions. Hence, this U star is continuous. It is continuous on D star. And now to show that it is harmonic, you have two ways to show. For either you show that it has all its partial derivatives, continuous partial derivatives up to first order 2, and it is a solution of Laplace equation. That's also a nice way to show, but I will go for the mean value property since it's a continuous function, and I will establish that this U star satisfies the mean value property. So let us fix some Z naught in D star, then then what do you say? Then this Z naught conjugate has to be in D, because D star is a reflected domain of D, and reflected domain of D star has to be D. So Z conjugate is in D, and U is harmonic there. U is harmonic there, and hence it is harmonic, so it satisfies the mean value property. So we have some a disk about this point in domain D such that U at Z naught conjugate is equal to the mean value 0 to 2 pi U at Z naught conjugate plus REI theta d theta upon 2 pi. In this way you have this thing, and what you can see now, and this is not something different to see now. Now see that this Z naught conjugate plus REI theta, it belongs to domain D. It's now in domain D, but yeah, if I write it in this way, okay, how do I see it in this way? Just a second. Okay, then this point Z naught uh, plus RE minus I theta, which is actually the, the conjugate of this number. It is conjugate of this number, and this element lies in the reflector domain D. You see, this is in the reflector domain T, and let's look at what happens for the average, and it lies in domain D, and indeed it is a part of it is it's a reflection of the circle of this radius R there. So let's see what is the average value of now. Average value of this number 0 to 2 pi u star at these points at that circle z naught plus r e minus I theta d theta upon 2 pi. By definition, we might use the definition of u star. And the definition of u star says that it has to be u of z naught plus r e minus I theta whole conjugate. It has to be d theta upon 2 pi. But this thing is nothing but this is equal to 0 to 2 pi, and this is u of z naught conjugate plus r e I theta. Now it will minus will not be there since we are taking the conjugate. It is d theta upon 2 pi, and you see what is this thing from here. Let me call it equation 1. From equation 1 you see that it is the value of u at z naught conjugate. So it is value of u at z naught conjugate, and by definition of u star this is nothing but this is u at u star at z naught. This shows that so what you have now, you have this value of u star at z naught is equal to the average of this u star on the circle of radius r. So this shows that u star satisfies the mean value property, or it has the mean value property. And if it has the mean value property, that means since it was already we have already established that it is a continuous function, so it is harmonic. It is harmonic on the reflected domain D star. Yeah, that's it. So okay, let's now state our main theorem, first main theorem, that is the Shiva's reflection principle for harmonic functions. What is it? It is let D be a symmetric. It has to be a symmetric domain with respect to the real axis, to the real axis, and let us take D plus to be the part of this domain that lies in the upper half plane, And for note that when we say that it is a symmetric with respect to real axis, that means it cannot be a domain which entirely lies above real axis or entirely lies below the real axis. That means it is a domain which is equally above real axis, and which is whose equal and symmetric part lies below the real axis. So it has to be this kind of type. It has to be symmetric with respect to real axis. So let D plus be this thing, and you know that this is something. That means this part is D plus. This is D plus. Okay, and let U be a real valued harmonic function. Real valued harmonic function, which is defined only on this D plus part. It is defined only on this D plus part. Okay, if we do not know its value or below on the D, this below part, the real harmonic function on D plus such that value of uz tends to 0 as z from this D plus tends to any point on the real axis, to any point of what is real axis. Real axis part is whatever part of real line is in this D. So it is given that this whenever we approach this real axis part, the function tends to the value 0. This is the part of the hypothesis, and the conclusion says that then U extends to be harmonic on whole of the domain D, and the extension satisfies the following equality. Satisfies this inequality. U of z conjugate is equal to minus U of z forever z in D. So what we have a harmonic function on a on a one part of the symmetric domain. Then it it vanishes whenever we approach to this real axis. Then the conclusion says that this function can be extended to a function defined on whole of a domain D, and so that the extension itself is a harmonic function, and it satisfies this inequality, that the value on it simply says that if you have a z on this D plus, what it implies that if z is in D plus part, then you know z bar is in this lower part. Z bar is somewhere in the lower part of this domain. Then the value, when you extend this function, then the value of that extension uh, has to be minus of the value of u in this upper part of the domain, or in the other D plus of the domain. So this is how this will work. So let us first, what do we have this? We have a domain. Let me again retry it here. Let us suppose we have a domain of this type which has to be symmetric. See, this we have three parts now. This domain is divided. One part is this upper part, which is D plus, and the other part of this domain is this lower part, which is nothing but which is the reflection of this upper part, and let us denote it as D minus. I am writing D minus because if you see that it is nothing but here the imaginary part of this Z is less than 0 intersection D. And the other part of this is this real axis, and this is D intersection R. So we note that this domain D is disjoint union of D plus its reflection, इसका D plus का reflection जो below the but the real axis होगा, its reflection which I have denoted by D minus, and the line segment D intersection R. So let us try to extend this function. We do not need to define it on the real axis because according to hypothesis on real axis, if you are extending it, it needs to be extended in such a way that its value is 0. So we only need to define this function in such a way that it is defined on this D minus part as well. So let us for Z in this D minus part define, let us extend this function to be u of Z to be since now Z is in lower part and its conjugate will be in D plus, and on dz, if Z is here, then Z its reflection will be here, it will be Z conjugate in the D plus part, and in D plus part u is a well defined function, so I can apply u on it, but we have to be sure that the values are not same, and so I will take the negative here. So we are defining u on this other part of the domain in this way, and I'm defining this uz to be 0 whenever Z is in this this segment D intersection R. So in this way, now look, see, from lemma, the lemma that I just proved, this D plus is a domain because it's open and connected, and D minus is also a domain, and D minus is a reflection of this D plus. So from lemma it follows that because we have seen that uz bar is a conjugate for a harmonic function, so minus of that is also a harmonic function. So we see that u is harmonic on D minus as well, and it was already harmonic on D plus by hypothesis, so it is harmonic there as well. So if it's harmonic, it satisfies the mean value property, but we want to show this extended function to be harmonic on whole of the domain D, and we will show it by using mean value property. So now if Z naught is any point in D, and we know that this D is disjoint union of 3 parts, and another part is the segment D intersection R. Now we have three situations, or two. Let us take two situations. Then let's first take this situation where Z naught is either in D plus union D minus, or Z naught is in D intersection R. Okay. Let us first look at this part where Z is in either D plus or in D minus. So you have this domain. Okay, let me retry it. I have this thing. This is D plus, and its similar image has to be D minus. Okay, it doesn't look that way, but let me try to. Yeah, this. So whenever Z is in this part, so either Z is in above part or is in, suppose Z is here. It's not on the real axis. So whenever z is here, it's a domain. We can always draw a disk, whatever radius it is, but that disk still lies inside that domain. And even if it lies in this d minus part, still this being open, we can draw a smallest disk in such a way that that disk doesn't intersect this real axis. So whatever disk you draw, then in this case, in this situation, we can always find a disk, find a disk at this point z naught, which entirely lies within d plus or d minus, depending upon आपके पास डिपेंडिंग अपॉन z कहाँ लाई करता है, डिपेंडिंग upon z belongs to d plus or z not is in d minus. d plus में होगा तो डिस्क एंटायरली आपके पास d plus में रहेगी, अगर नेगेटिव नीचे वाले पार्ट में होगा तो डिस्क उधरी होगी, ठीक है. But in both these parts your function is harmonic, and since uh, u is harmonic on d plus and d minus, so u value of u at z naught will be equal to 0 to 2 pi u z naught plus r e I theta d theta upon 2 pi. So in that case, you will always satisfy the mean value property, whatever z you take in any part of this, except when z is not on the real axis. Okay, so it satisfies the mean value property whenever you take z in d, but now the only thing that remains to show is that when z is in this segment. So now let's look at now the situation where you have where we have this z. Next, let us take z naught be in this segment. Okay, in this part. So we have this. Let me retry it. Okay, now say now at this time we are choosing z to be somewhere here. Okay, what happens then? Then whatever disk we draw, there the part half of that disk will be in d plus and half of that disk will be in whatever radius we take. This will be always the case. Then for any d z naught with epsilon, but the disk has to be in d. Let's look at the average value. What is the average value then? Then the average value, I'm not looking at minus pi to pi instead of 0 to pi. Value of z naught plus r e I theta for any r in such a way that this circle lies inside this disk of radius epsilon, d theta upon 2 pi. So now I have two parts now of this circle. One part that lies entirely, and the orientation has to be anti-clockwise, and the orientation is in this way. But when we drop, when we let me draw this circle separately. I have this circle and I have part of real axis in it. I have to divide it into two parts. and the first part will be this path. No, no, this way. It has to be this direction, this way, and then I will follow this path. Okay, and the other mm, part of this circle has to be divided into, but then the orientation will be different. Okay, you have this way. We have this way as well, and here it is. Okay, now you see what is in it. Mm, This is, if there is a point, if there is a point here, if this is a point z naught plus r e I theta in the upper semicircle, which is part in d plus, then its reflection is a point which is z naught plus r e minus I theta. It lies in the lower half circle. Okay, so let's divide it into two parts. Now, first thing, it has to be minus pi to 0. We are starting from this point to this point, and because we can break, because this part, that is this segment part, will be cancelled out, because here once you go through from right to left, and in another turn you will come from left to right. In both the cases you will have opposite directions, and that part will be cancelled out. So we'll have integral minus pi to 0 u at z naught plus r e I theta d theta upon 2 pi, and plus you will have integral 0 to 2 pi, 0 to pi, another part in the upper part of this circle. This is u z naught plus r e I theta d theta 2 pi. So now you see these, I broke this average into two parts, and the let's go further. Now see, let's look at this. The reflection of the part of the semicircle, indeed, semicircle z naught plus r e I theta, in this case minus pi is less than theta less than 0. This is the semicircle, and its reflection is the semicircle in the upper part, is the semicircle. Its reflection has to be z naught plus r e I theta conjugate. Again, you write it minus pi less than theta less than 0, and this thing is z naught plus r e minus I theta minus pi less than theta less than 0. But z naught is a real number now, so z naught conjugate has to be z naught. So when you take, when your theta is lying between minus pi and minus pi and 0, so you may write it as r e. Then look at, let's like this, minus pi is less than theta less than 0. This will simply imply that 0 less than minus theta less than pi. So minus theta lies between, I may write it as minus 0 less than minus theta less than pi. Again, let me replace theta by minus theta by theta. It's a variable, no issue. Z naught plus r e I theta such that 0 less than theta less than pi. So this is the reflection of this semicircle in the lower half, is exactly the semicircle in the upper half. So Then let's look at this thing, how you define. Hence, this average minus pi to pi of u at z naught plus rei theta, which is equal to minus, first I had minus pi to 0. It is u at z naught plus rei theta d theta upon 2 pi. And another part is uh, 0 to pi. It is u z naught plus rei theta d theta. So the first integral is is defined in the lower part, that is d minus, and in 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 lower part, how we have defined this u. Here is the definition. Here is the definition. It is minus of uz conjugate. So it has to be minus pi to pi. It has to be u and conjugate of z naught plus rei theta into d theta upon minus of this thing 2 pi, plus let it be as it is here. And now as seen, I can write this because this number z naught conjugate plus rei theta will be an element in the upper part of this semicircle. It will be in the upper semicircle, and there I can take value of integral to be 0 to pi, and without any hesitation u will be defined in this way, and I can write it z naught plus rei theta again, because theta must vary from 0 to pi. 2 pi plus, again it is 0 to pi, u z naught plus rei theta d theta upon 2. Now you see these two values are uh, opposite to each other in sign, so they cancel out and the total value is 0. And the value at 0, you can write it to be value of u at z naught, because z naught is lying now on the real axis, and on the real axis you have defined u z naught to be 0. So it coincides with this. Hence we can say that the value of u at z naught is equal to average value of u on the circle of radius r, and that is what is the mean value property. Hence, in this way, whenever z naught is in on the real axis as well, the function u satisfies mean value property, and for hence u has the mean value property for every point on the domain D. Hence, therefore, it implies that U is harmonic. U is harmonic on T, and clearly ये तो definition से ही follow हो जाता है कि UZ conjugate जो है UZ conjugate is minus of UZ. UZ ऐसे ही extend हमने किया हुआ. Is it okay? बोलो. You have any query? Am I audible, by the way, to you?
Yes, sir.
Yes, sir.
Okay. So I think this is enough for today. And if you have any questions, please kindly go ahead.
No, sir.